Today's video is for section 2.3. We're going to combine like terms today. So we're going to explain a couple things to you up front and then show you some examples. So how do we know what like terms are? There's a couple terms we have to become familiar with first. And the first one is a coefficient. You've probably seen this. This is a very fancy word, but it doesn't really mean anything except it's the number before a variable. So this 2 right here, 2x, the 2 is the coefficient in front of the variable. The next one that we have to look at today is a constant. When we look at an expression like we have above, where we just have a number here all by itself, that number 4 is a constant. It doesn't change. Nothing is variable with it. So to help you understand combining like terms, I'm going to look at just something like combining like shapes. Now obviously you see a bunch of squares and triangles and circles up there. So what do you say we were to put all of them together and group them? What would that look like? Now I'm going to play a little magic here and I'm going to sort everything. And voila, I put all those terms together, and now you can see that I put all the squares together, I put all the circles together, and all the triangles together. So now if we were to just count the number of squares, well, let's just do it this way. We'll bring the number of squares up and we have 1, 2, 3, 4, 5. So we have 5 squares. Now we're still going to add them. So we're going to steal this little plus sign right here. 5 squares. How many circles do we have? We can move this over and we have 1, 2, 3 circles. 3 circles. And we'll steal another plus sign. And we also have triangles here, so we can use this triangle down here. We have how many triangles? We have 1, 2, 3, 4 triangles. So our coefficients for those terms become 5 squares, 3 circles, and 4 triangles. Now, we can't put them together any further because you can't combine a square with a circle. So we're going to keep these all separate, and that's going to be simplifying that expression. So what you looked at in the first part of this video, everything got combined. We have actually combined like terms. Now when we looked at these with shapes, it was pretty easy, but let's look at this example. We can do the same thing we just did. We can combine the different variables. Now we can't combine a's with b's, so let's put them together, and before your very eyes I'm going to have these sorted, and voila, I've put all the b's together now. I've put all the a's together, and I've put the c's together. I've grouped them. So let's take a look down the bottom now. How many b's do we have? We have 2 b's, so the coefficient of the b term means simply 2b. That means 2 times b. We have 2 b's. We have 3 a's, and 2 more c's. So that expression simplifies into 2b plus 3a plus 2c. That's all we have to do for that to simplify that expression. Now the same thing can happen to identify like terms. Now you can see I have 3 boxes here. I have a box of just x terms, I have a box of d squared terms, and I have a box of constants. So all we're going to do is go around our board and put these together. So here we simply have a d squared. That's going to go over there. Negative 5d squared. That's going to go there. 25 has no x or d. That has no x or d. Here's an x. That goes over with the x's. That goes over with the x's, and here's a negative sign. We're going to talk about that in just a second. And why doesn't that want to go in there? And 4d squared goes here. And 0, yes, 0 is also a constant. So you can see I've grouped these terms together. And now what we would do is combine them. So we're going to combine them in the next part of this video. All we're going to do is combine like terms. So we have 35x plus 15x. Well, we know that 35 plus 15 is 50. So this is not just going to be 50, it's going to be 50x. Think about that term in terms of like apples. If you had 35 apples and you added 15 apples, you would wind up with 50 apples. Now I told you that negatives were coming, so what we're going to do here is we're going to take 12x plus 8x minus 7x plus h. So now we're just going to combine these terms left to right. Now again, the h is a separate term, so we're never going to do anything with that with the x's. But if we add 12x plus 8x from all the work we did with order of operations, we have 20x minus 7x plus h. And now we can further combine this. If you have 20 x's and you take away 7 x's, you have 13 x's plus h. So again, you can't combine the h and the x, so we're simply done right there. And the final example I want to do for you today involves your good friend from yesterday, the distributive property. So again, you'll see what I put in the notes here. It says simplify using distribution first. So if we bring down 5x plus 2, now let's look at our distributive property. We're adding, we have to multiply 3 times x to get 3x, and 3 times minus 1 to get negative 3. And now we have to group the coefficients and variables together. So we're going to look at combining the 5x and the 3x, and then the 2 and the minus 3. So if we put these together, it's simply going to be 8x, and then positive 2 minus 3 is going to be a negative 1. So to simplify this whole expression using distribution, 8x minus 1. You're going to begin your classwork right now.